Example 5, we're going to find the volume of a parallelepiped. Very fun word. This word here, parallelepiped. So a little bit on that, we're going to look at the triple scalar product. So for u and v and w, so I hope you see that here. So u sub 1i plus u sub 2j plus u sub 3k, and then v and w. The triple scalar product is this. So u1, u2, u3, v1, v2, v3, w1, w2, w3. When the vectors u, v, and w do not lie in the same plane, the triple scalar product u times v times w, it determines the volume of a parallelepiped. It's a polyhedron whose faces are all parallelograms, with u, v, and w as adjacent edges. And so here is a picture down here. So a couple pictures. So these are parallelograms. So each of the faces are parallelograms. And notice it is not on the same plane. So the volume v of a parallelepiped with vectors u, v, and w as adjacent angles is this. So v equals u times v times w. So it's the area of the base, which is v times w, the magnitude of v times w. Then we multiply that to u. So notice this here. So let's try that. Find the volume of the parallelepiped that has u, v, and w as adjacent edges as shown. So notice here, I went ahead and wrote the equations just because in your example that you'll see in the book, is you're going to be given the equations and not necessarily the points here. And then if you are given the points, you know how to write it out. So notice u is 3, negative 5, and 1. So that's written as 3i minus 5j plus k. Then v here is 0, so 0i, 2j minus 2k, and w is 3i plus j plus k. So let's find this product, u times v times w. So u is 3, negative 5, and k. So that's our first line, 3, negative 5, and the coefficient, which is 1. Then v, we have no I, and then 2 and negative 2, so 0, 2, negative 2. And for w, it's 3, 1, 1. Then we're going to use the diagonal method, 3, 0, 3, and then negative 5, 2, and 1. So we're going to multiply and add these here. So that will be 3 times 2, that is 6, and then negative 5 times negative 2 is 10 times 3, which is a positive 30. 1 times 0 times 1 is 0. Then we'll subtract the products going up. And so this is going to be 3 times 2 times 1, that is a 6, but minus 6. This is 3 times negative 2 times 1 is negative 6, so minus a negative 6. And then 1 times 0 times negative 5 is 0. So then let's simplify. This is going to be negative 6 plus 6, that's 0. And then this is 36 here. Now when we're finding it, notice that we have the absolute value. So we are looking for volume, so it needs to be positive. So if it's ever negative, just make sure that it is positive. So therefore, the volume of this parallelepiped is 36. Very fun word. Now try this example on your own. Find the volume of the parallelepiped that has u, v, and w as adjacent edges. And so u equals 2i minus j plus 4k, v equals I plus 3j minus 2k, and w equals 2i minus 2j plus 3k. So if you tried this out, the volume you would find is negative 15, so it's positive, so the volume is 15.